In this video, we will be learning about nomenclature for binary ionic compounds. We will be focusing on writing chemical formulas for binary ionic compounds and naming binary ionic compounds. Then in subsequent videos, we will build up to increasing complexity. So when we write the chemical formulas for our ionic compounds, we have to remember that ionic compounds are always neutral overall. That means that the sum of the charges of the cations must equal the sum of the charges of the anions. That way everything adds up to 0. So there's no charge at all. We also have to remember that when we write subscripts in our chemical formula, it doesn't represent charges, it represents counts of atoms. So when we write our formula, the chemical formula for our formula unit, these subscripts have to indicate quantity. And so if we look at an example where we have sodium ions and oxide anions, we have that's a +1 and that's a 2-. In order for this to add up to 0, right now those add up to -1. And so that's no good. I'm going to have to add in a second sodium ion so that that adds up to 0. So now the sum of all my charges adds up to 0 and my atoms are happy. So I had to use 2 sodium atoms. And so I put a subscript 2 after the sodium to indicate that I had to use 2 sodiums. 2 sodiums, 1 oxygen. A 1 subscript is implied, so we don't write 1 subscripts. Next up, we have sodium and chlorine. Both of these have, that has a +1 and that has a -1 charge. And so those add up to 0 with just 1 of each. And so I just need 1 of each to make it neutral. Here we have calcium and oxygen. Calcium is a 2+, oxygen is a 2-, that's their common ion charges. And so those add up to 0. And I just needed 1 of each to do that. So both of them have an implied subscript of 1. Calcium is a 2+, common ion charge. Chlorine is a 1-. And so in this case, I'm going to need 2 chlorines in order to make this overall neutral. The sum of all these charges has to add up to 0. I can't just change the charge on the chlorine. I have to just add more chlorine 1- anions. And so that is CaCl2. The subscript 2 comes from the fact that there's 2 chlorine ions. One way of getting the subscripts is to do what's known as a crisscross. And so you take your subscripts, or to get your subscripts, you crisscross the charges. And so the 3+ becomes a 3 on the oxygen, and the 2- becomes a 2 on the aluminum. If you do this method, you do have to realize that if you end up with something that has common denominator, lowest common multiple, you need to simplify, because our ionic compound formulas are always the lowest whole number ratio. I say that, but it is that represents the cation and anion. So lowest whole number ratio of cation and anion. And so calcium and oxygen, I just need 1 of each in order to add up to 0. And so the lowest ratio of cation to anion is 1:1. Here, aluminum is 3 plus, oxygen is 2 minus. If the sum of the charges right now is a plus 1. So I have to add another anion in order to lower that down. So I add another anion, and now my overall charge is not plus 1. Now my overall charge is minus 1. And so then I have to add another cation in order to make that positive. And now it's going to be a positive 2 charge. And so now I have to add another anion in order to lower that down. And I'm getting ahead of myself. But now the overall charge is 0. And so now that the overall charge is 0, I count up that I have 3 oxygens and 2 aluminums. So that shows you that the lowest common, you can also think of it as lowest common multiple of 2 and 3 is 6. And so I have to have 3 2s in order to get up to 6. And I need 2 3s in order to get up to 6. So many different ways of getting your subscripts. Let's go ahead and practice writing chemical formulas for the different pairs of cations and anions in this table. Go ahead and pause the video and write chemical formulas for these things, and unpause the video when you're ready to double check yourself. All right, let's go over this. Aluminum and chlorine, I will need 3 chlorines in order to make this neutral. Then I will need, that's going to be neutral with just one of each, and so that's just going to be GAN. And then here I'm going to need 2 sodiums in order to cancel out the charge of the sulfur. And so I'm going to need 2 sodiums. And so I'll write Na2S. All right, when we're naming our binary ionic compounds, we will only be naming 2 different, like 1 cation and 1 anion. There are more complicated ones out there, but we will be just doing 1 cation and 1 anion. The name comes from the name of the cation, which is the metal, and then the name of the anion, which is the nonmetal that has a an "ide" suffix. And so they say base name because the different elements have different letters that come off, and it takes a while to get used to which letters come off of the name in order to change the name to have an "ide" suffix. But when we name these, all of these have common ion charges that are shown here. And so this first one is just aluminum. And then the second word is going to be chloride. This is gallium. And that's nitrogen. And so that's going to be nitride. Where did I write it? N. Nitride. So nitrogen becomes nitride, chlorine becomes chloride. This is sodium, and so that is sodium. And that is sulfur, and so that becomes sulfide. So this IDE ending is applied to the second word only. And so we didn't even need to look at the chemical formulas. We just had to look at what the cation element was and what the anion element was. Type 2 ionic compounds do not have common ion charges for the cations. And so the naming is just one extra step. we're still going to have the name of the cation followed by the name of the anion with an "-ide" suffix. However, we have to indicate what the charge was of the cations, because you would need to know that in order to come up with the chemical formula. If you're trying to work backwards and you have the chemical formula and try and come up with the name, all of the anions have predictable charges, and so you can infer from what the anion is and how many of everything there is, what the charge of the cation must have been. Here's an example table. So for this first one, chlorine has a common ion charge of -1. So I know that I have 3 chlorines. My charges have to add up to 0. That means my cation has to be iron 3+. Now I can name my compound, now that I know what my cation and anion are. That's going to be iron, Roman numeral 3, chloride. My chlorine gets an IDE suffix to indicate that it's in an anion form. Next, I have to work backwards. And I know that it says iron 2. And so iron 2 has to be iron 2+. Chloride is Cl-. So I have to form a neutral ionic compound between iron 2+ and chlorine 1-. Next up, I have to figure out my cation anion here. Oxygen has a common ion charge of 2-. And so copper, there's 2 coppers, and so that means each copper has to be a +1. Now I can name my compound copper 1 oxide. Oxygen becomes oxide. It doesn't become oxygenide. It just becomes oxide. So, review of Roman numerals, that's 1, 2, 3. I'll go ahead and put the bars there. Not the fonts don't always have the bars. But 4, 5, 6. That's not 6, that's 4 again. Okay. Here's a table for you to practice naming. Go ahead and pause the video and try to work it on your own, and then unpause the video when you are ready to double check yourself. Remember to show your work in your notebook. All right, let's go over this. So vanadium 5. So that means my cation is vanadium 5+. Oxygen is a 2- common ion charge. So my chemical formula using the crisscross method is V2O5. Next up, I have zirconium and sulfur. So zirconium, well, sulfur has a common ion charge of 2-. It's right underneath oxygen. So sulfur is a 2-. I have 2 sulfurs, so my zirconium has to be a 4+. So that is zirconium. How do you spell zirconium? Zirconium 4 sulfide. Yeah. Now we have the next one. Bromine has a common ion charge of Br. So always start with the anion when you're trying to interpret. Those have common ion charges. I have 2 bromines, and so that means my lead has to be a 2+. And so that's going to be lead 2 bromide.